if I don't like tomatoes, Sam? Future where I eat fresh tomatoes every morning is a dystopia. All right, so I'm here to present the Space Team Project. I'd like to start with a question. What's the best example from the last century of an exponential technology that has truly had 10 to the 9th plus impact? I would say it's computers. You know, we take computers for granted, but you can't do anything without a computer being involved somewhere. Computers are the backbone of virtually all human activity. We all know that computers are in our air traffic control, they're in our cars controlling our steering. You know, it's the backbone, obviously, of our communications infrastructure. We all know computers are everywhere today. But I would argue that the space industry today is where computers were in 1945. Expensive, impractical, huge, primarily utilized for government applications and expensive commercial operation. If you were to propose in 1945 that you were going to do a project to impact 1 billion people using computers, you would have been laughed out of the room. Because no one could imagine how computers would evolve to change the world. I would argue that we are in a unique position to lead the space industry through those same transformative changes that the computer industry went through from 1945 to 1995. And I'm going to go through some analogies between those transformations in the computer industry and the developments that we in the space team are working on right now. First of all, computers in 1945 had to keep all the data that they were going to work with internally, just as rockets today have to keep all the fuel that they're going to work with inside of the rocket. But just as computer technology was greatly enhanced in utility by the invention of networking and the ability to use data that's streamed in from externally, so we're going to transform the utility and the price performance of rocket technology by enabling energy to be beamed in via microwave from a ground-based station. This is our cheap access to space beam power group. Next, computers in the 1950s were facilities. If you wanted to do anything in your business involving computer technology, you had to outfit basically an entire room, you had to staff it with trained technicians, and it was a huge capital investment that you would have to make to do anything involving computer technology. In the same way, today, in space, if you want to create some business in space, you have to make a huge capital investment in an orbital facility, and you have the risk that something might go wrong, and it's pretty hard to get anyone out there to repair it. And in the future, space will be like computer technology today, where you manage your computing assets as a virtual utility subscription. Twitter doesn't have any data centers. Their providers like Amazon Web Services and Google App Engine enable you to purchase virtual computers. They manage the facility, and you just worry about your application. In the same way, we in the space team have a swarm project to create a large number, hundreds or even thousands or tens of thousands, of orbiting satellites which will be shared. We will rent them out to businesses that want to do some sort of operation involving space technology. You'll amortize the launch costs, you'll amortize the risk that one of these spacecraft will fail, and with the ability to move software from satellite to satellite as they're going around the Earth, you can create a virtual geostationary satellite without launching anything higher than low Earth orbit. Next, computers in the 1950s were all made by hand. They were designed as one-off projects and assembled by, essentially, scientists. In the same way, spacecraft today are designed as one-off projects and assembled by, essentially, scientists. But today, computers are recursively improved because we make computers leveraging the computer technology that we already have. And in the same way, in the future, we're going to have our spacecraft actually made in space, using space technology to recursively improve and create accelerating returns. And we have a group called Made in Space that's looking at some really interesting 3D printing technologies for making spacecraft that are designed for the environment that they're going to operate in, rather than to withstand the rigors of a high vibration, high acceleration launch process. It's only 10 minutes before you actually get into the operating regime. Another thing that we need in order to make a transformation like that in the computer industry is a killer app. Something that's going to drive, well, why would you want all of this stuff to be cheaper? What's the point? And our proposal is life, biology. There are a lot of interesting preliminary results that certain diseases can be treated using microgravity, and that there are some avenues of biological research that are very difficult to pursue on Earth, and that having an orbital facility for doing this research might be very beneficial. In addition, we have a group looking at biomimicry and utilizing biological principles to design materials and structures that will house humans and support their biological systems as we explore the solar system. But our long-term vision for where this is all going in the deep future is not human biological wetware being transported in bottles of Earth, but rather that intelligent systems will explore the universe in a form that is more suited to the environments in which they inhabit. This will be achieved through telerobotics, or eventually, as we go further out, through human-level artificial intelligence. So just to sum up, we have cheap access to space, CAT's team looking at microwave beam power. We have our SWARM team looking at the cloud computing of space. We have our Made in Space team working on recursive self-improvement by using space technology to make space technology. Our Space Bio team looking at biological research that can only be performed in microgravity. We have our BEST team, Biologically Enhanced Space Technology, looking at biomimicry, structures and materials. And finally, our AI Labs group, looking at the applications of the true singularity artificial intelligence trends to space exploration. On behalf of the space team, thank you very much.